Hello, and thank you for watching this video, which is the third in the series of SQL reviews for table joins. The query that you currently see was the last query executed in the second join review video, in which we determined for each customer the number of orders placed, the total number of line items across all of those orders, as well as the order total, meaning the total value of those orders placed by that customer. We also determined that we have 19,119 rows in the result set for the first query. However, we have 19,820 total customer records. That leaves us with a difference of 701 records. Now, SQL Server is not making a mistake. SQL Server is providing us with exactly what we asked for, because we asked for all of the sales order headers joined with the sales order details on the sales order ID key value, and that joined with the customer table joined on the customer ID value. The 701 missing customers is as if it were, are customers who have not placed an order. So there is no sales order header record for those customer IDs. Management may be interested in determining which customers we have in our database that have not yet placed an order with us. We can do this in a number of ways. I will show a solution first that will simply list the customers that do not have an order placed. But then in a second phase, we will move towards writing a query that will combine all of the customers, in other words, those that have placed orders and those that have not yet placed orders, and show the order total for those customers for which it's available. Now, if we are only interested in determining which customers have not yet placed orders, we can do a query that is still a multi-table query but uses a subquery clause that does not use a join clause, and we will do that as such. So we will take the customer ID and the account number from the customer table, but we're going to use a where clause, and we are going to say where not exists, and I think that clause is self-explanatory, where we do not have any records returned from the following query, which is select star from sales order header, which is also in the sales schema. And we are going to query for sales order headers where we have a customer ID that matches the customer ID from our first table. So this is still a multi-table query because we are querying the sales order header and the customer table in a single statement, but it does not require a join statement. We are simply saying that we want to look at the results of this query where we find sales order headers with a particular customer ID, and then we want to say from the customer table, then select those rows where we have no match in the second query. Now, if we execute this statement, we should find 701 customers, and that's their customer ID together with their account number. So this is one way of solving this particular problem. We are able to find the customers that have not placed orders yet. But what about creating a single list that includes all the customers, and for those customers that have placed orders, we find their order total and the number of orders that they have placed, and for the customers that have not yet placed any orders, we can then just maybe show zeros. So we will move back to the query on top. I'm going to remove this count star that counts the number of line items, as that's really not such useful information. And I'm going to revisit something I mentioned in the first join video, which was that we generally want to start the from clause with the most important table, and in one-to-many relationships we would consider that to be the parent table. The real parent table in this sequence of 3 tables is actually the customer table. So just for clarity's sake, and please understand there is no technical reason for doing so, I'm just trying to make the query as clear as I can. Just for clarity's sake, I'm going to move the customer table up first. Now I'm not making any changes to the outcome of the query. I'm just rearranging the order in which my tables are listed. But at this point, syntactically speaking, I have the exact query as before, and as a matter of fact, we'll go ahead and execute this query. We will see that this data looks very similar to the first set of data I have, and we can then see that the same number of rows is indeed returned. This still only gives me the customers that have actually placed orders. The reason that this query gives me the customers that have already placed orders is simply because I have a inner join statement that is looking for a match on customer ID. By definition, customers that have not placed orders are not going to have their customer ID anywhere in the sales order header table. Therefore, they are excluded from this result set. So enter the outer join statement. There are two types of outer joins, and one is the left outer join and the other is the right outer join. Now, there is no real difference between a left join and a right join. It simply means that we are going to take all the rows from either the left table or the right table, and then only the matching rows from the opposite table. Let me show you an example. If I choose to use the left outer join statement in this case, then this means that I will take all the rows from the customer table, but only those rows from the sales order header table where I have a match on customer ID. If I flip around to using a right outer join, this simply means that I'm going to be using all rows from the sales order header table, but only those rows from the customer table where I have matches. Both of these are perfectly valid statements, but only one is going to achieve what I am looking for. Now it looks as if the results are different, but this is merely a sort order difference. Still returns 19,119 rows. Remember that this right outer join is going to take all the rows from the sales order header table because it's on the right hand side of the join statement, and only those rows from the customer table where I have a match on customer ID. Well, in this particular scenario, because of the way the database is defined and used, I have done nothing different than if I had written an inner join statement. But what if I choose to do a left outer join, meaning that I'm going to take all the rows from the customer table, because the customer table is now on the left hand side of the join statement, and only those sales order header rows where I have matching customer IDs. For a particular syntactical reason, I also have to change the second join statement to be a left outer join. Now I'm just writing left join because the outer keyword is actually optional. So left outer join or left join are identical statements. If I execute this query, I'm now going to receive the expected 19,820 rows, meaning that I have one row for every customer in my customer table, regardless of whether or not they have placed an order. And if I scroll down my result set, we will find customers that have no order total, as indicated by the null, and the count of the number of orders is 0. Why did I have to use a left join statement when I'm joining the sales order detail to the sales order header? Could I not just use an inner join here, because after all I'm only looking for matches on sales order ID. There is no match here for customer. But if we execute the statement like that, we find that we only get the 19,119 customers who have placed orders. What happened? This is a SQL specific anomaly. Now there is a way to be able to write the join between sales order detail and sales order header as an inner join. We will have to use parentheses in order to make this happen if we want the customer table to be the first listed table. We will have to say that we are going to select from the customer table, left outer join it to the sales order header table, which is inner joined with the sales order detail table on the sales order IDs, and then close the parentheses. So this is a slightly different style of query, and with some indentation we can hopefully make it a little bit more obvious. So if we look at the position of the parentheses, we are essentially, as parentheses usually do, indicating to SQL Server that this join, which is now an inner join, needs to be executed first. Afterwards, we will join the customers table as a left outer join, matching the customer IDs there. So this requires us to split the join condition from the actual join statement, which may also be somewhat harder to read. So therefore, a third option to get this to work, which is my personally preferred option for writing join conditions like that, is to keep the left join and the inner join not using any parentheses. Well, in this case it will become a right join, not keep any parentheses, and list the customer table last with this right join. So even though in general the customer table might come first because it's the parent of the sales order header table, because we want to avoid using parentheses and we still want to indicate that sales order header and sales order detail are inner joined, we can write the join condition as such and execute this statement, which will give us the 19,820 rows that we were used to. So in short, there are multiple ways of using right and left joins to make sure that all rows from a particular table are included, even if there are no matches on their key fields. The preferred method might be to have all the right joins and left joins listed at the end of your from statement. Alternatively, you may have to revert to using parentheses. Thank you for watching this video. Till next time.